In today's mini lecture, I am going to show you how to, and model for you, how to draw the nucleic expression, use the nucleic expression to draw the electron configuration, and then finally do an orbital diagram drawing for an element. The elements that I've chose to do for you as a model is going to be sodium and chlorine. Before we start, I'd like to just simply go through, give you a quick little review, how to write the pattern. So first we number 1, 2, 3, 4, 5, 6, and 7. Number 1 to 7, which represents the periods on the periodic table. Then we're going to go through, and each number will receive a little s. I'm going to go over 1 and down 1, and each of the numbers will receive a little p. Then I go over 1, down 1, and each will receive a d. And then finally, I go over 1 and down 1, and I write in my f's. Always remember that we start in the upper right, working our way back down to the lower left. So I'm going to draw a line, and the pattern says line goes through one letter, 2 letters, 2 letters, 3 letters, 3 letters, 4 letters, and then finally the F. So I'm going to go back in. I'll write the pattern out now. That's my drawing for the pattern. And then to write the pattern out, I'm going to start up here. It goes through the S on the 1 level. I come back up. Now I'm going to go through the S on the 2nd level. Then I go through the 2P and then the 3S. Next will be the 3P, 4S, and 3D. All right, so I am currently right here. I'm now at my 4P, so I'm gonna write 4P, 5S, then it'll go back to 4D, 5P, 6S. Now I'm back up here to 4F. And then I'm coming back down 5D, 6P, 7S, and finally I have the 5F. This shows me the actual pattern, or the way that these orbitals will fill up from the lowest energy to the highest energy. So next I'm going to do the nucleic expression for sodium. Sodium is going to be Na. It's going to have 11 and an atomic mass of 23. So its pin number is going to be 11 electrons and 12 neutrons. So we have 11 electrons. So that's the important number whenever we're dealing with electron configurations. We're not looking at the nucleus any longer. We're looking at the electrons and how they appear in the orbitals. So what I'm going to do is I'm just going to start right here with the 1s. I'm going to write that down. Now, if you remember from yesterday's notes, we went through and we said an s orbital can hold 2 electrons. So when I look at this, I have a total of 11 electrons. So I'm going to put a 2 right there. Now, please don't get this mixed up with an exponent. This is not 1s squared. It's 1 being the period, s being your orbital, and 2 being the number of electrons. All right, the next is 2s. And again, it doesn't matter if it's the 1s, 2s, 3s holds 2. So as of now, I have placed 4 of the 11 electrons. So I'm going to come back in and say 2p. 2p holds, the p holds 6. So now I've got 2, 4, and 6 more is 10. But I need 11. So what's after the 2p? 3s. So I'm going to go 3s and a 1 right there. So that is going to be the electron configuration for sodium. Your orbital diagrams, fairly easy. This is straight off of the notes yesterday. We're just going to start applying them. I'm going to draw a box right here. And in that box, I'm going to put 1s underneath it. But now instead of writing a 2, I'm going to actually draw the electrons out. If you notice, I drew an arrow up and an arrow down. 1, 2. Now I'm going to go to the 2s, arrow up, arrow down, and again 2s. Now if you remember, the p box actually has 3 boxes in it. It looks like this because that p orbital will hold a total of 6. So as I place the electrons in, 1, and then 2, and then 3. Notice that I didn't double up. You always fill up each one of the orbital boxes before you go to the next step. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one's full. And finally, I have 1, and that is going to be my orbital diagram for sodium. So I'm going to do it again. I'm going to slide over just a little bit so that I can get chlorine in here. So I'm going to do the nucleic expression. Chlorine is going to be 17, has a mass of 35, so that's going to give me a pin number of 17, 17 electrons, and 18 neutrons. And again, what I'm more looking at is going to be the number of electrons. So I'm going to come back over here and say, all right, 1s squared. Actually, I said s squared because I was so used to doing it. It's 1s, 2 electrons, 2s, 2 electron, 2p, 6 electrons, 3s. And guys, remember, this one is 2 electrons this time because I have a total of 17. So as I've gone through here, I've got 2, 4, 10, and then I've got 11, 12. So I've placed 12 so far. Now I'm going to go 3p, and then if I'm trying to get 17, I've already placed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I only need 5 more. So I put a 5 right there in that last P. And what that does is that gives me a total of 17 electrons. So now on the orbital diagram, I would draw a box. I would label it 1s. I would draw another box, and I would label it 2s. Then I have a box that has 3, so I'm going to fill it up. 1, 2, 3, 4, 5, 6. Then I'm going to, that's my 2p. And then that is my 3s. I left 2p out. And then that's full. And then finally, I have the last orbital, which is my 3p orbital, and it has 5. So I'm going to fill up each box. 1, 2, 3. Each box gets 1 before I start doubling up. 4, and 5. So that is going to be the orbital diagram for the chlorine as well. Last thing that I want to go back in and show you is how can you go through and write the what is known as the noble gas configuration. Well, the noble gas configuration is nothing more than an abbreviation of the electron configuration. So if I look at this, do you see how if I count the number of electrons, 1, 2, 3, 4, and then that's 6 of them, that's 10. If I was to say what element on the periodic table would have 10 protons and 10 electrons, that would be neon. Neon is a noble gas. So I can do this by writing neon, and I put it in a bracket like that, and then that represents those, and all I'm left with is 3s1. Kind of shortcut a little bit. Same thing over here. Instead of writing that out every single time, over and over and over and over, I know that starting right here is neon. So I'm going to do the same thing. I'm going to put neon, put it in a bracket, and then I'm going to come over here and say 3s2, 3p5. So that is called the noble gas configuration. I hope, as in summation, let me tell you what we have done. We reviewed how to write, draw, and write out the electron pattern for the electron configuration. We've also chose 2 examples, sodium and chlorine, and we drew the nucleic expression, the electron configuration, the orbital diagram, and finally, we did the noble gas configuration. And I'm just going to write that on there, config. All right, so we wrote the noble gas configuration. I hope this helps you, and we do have a couple of practice problems that we're going to be doing after you have finished this video. See you later.